So this is 7.1c in unit analysis dealing with length. We're going to do 3 examples here that are story problems, starting with example 6. So we've got a sheep rancher who's making pens, and each pen is 6 feet wide and 8 feet long. So it's 6 feet wide and 8 feet long. The fencing material he wants is $1.36 per foot. So I'm going to put per foot. So every foot of fence is $1.36. Alright, and he's planning on 5 of these pens. So that being the case, he wants to know how much it's going to cost him for the fencing material if it's $1.36 per foot. So what I'm going to do is I'm going to find the perimeter of each one of these. I need to find how many feet of fencing he needs for one pen, multiply that by the 5 pens that he needs, and that'll tell me the total amount of fencing he needs, and then I'm going to multiply it by $1.36. So if the width is 6 and length is 8, then this is going to be, that's going to be 8, and that's going to be 6. So if I add all these numbers together for perimeter, for each fence it's 28 feet. And he's got 5 pins. So I can add 28 plus 28 plus 28 5 times, or I can just multiply 28 times 5 and get my total length of fence. So once I get my total length of fence, I multiply that by $1.36, and that will tell me how much it's going to cost to build all 5 of those pins. Example number 7 talks about Robert McKeague, who became the first 80-year-old to finish the Ironman Hawaii Triathlon, and it says that he ran 26.2 miles in 6 hours. So what is his speed in miles per hour? So if he did 26.2 in 6, how far did he go in 1? So a couple ways you can do that. Let's just look at one. If we just divide 26.2 miles by 6 hours, that will tell us how far he went in 1. So 26.2 divided by 6 is 4.36 miles per hour. So pretty quick and simple there. And finally, example 8, that's the one I really want to focus on because it's got really the true conversion. So we've got a ski resort in Vermont. Once advertised their new high-speed chairlift, had a speed of 1,100 feet per second. Show why the speed cannot be correct. Okay, so one of the things about speed is we're used to determining miles per hour. I have no idea how fast feet per second is. So everything in my world is around miles per hour. So what I'm going to do is I'm going to change this to miles per hour. And this is a little bit not tricky as much as a little bit different than we've done as far as the conversions, but it's important to do because you will run into these a lot in math. I call it a double conversion because in the past we were changing like feet to minute or feet to inches or inches to miles or something like that. It was just one conversion going from one length to another. But in this particular one we're going from feet to miles, because we want to change it to miles per hour, and we're also changing the seconds to hours. So instead of feet per second, we're going miles per hour. So we've got 2 conversions there, feet to miles and seconds per hour. So that's what we're going to do in this one. So get ready for a little bit different way of doing this conversions. Okay, so here we go with example 8. I'm going to write this as 1,000. As 1,100. Let's take that out and put 1,100 feet per every second. So I'm just going to put a 1 second there. So 1100 feet per second. And I'm going to make my times, and I'm going to make my line. And I'm going to put my feet down here. And I'm going to think about, is there any conversion I know that's going to take me from feet to miles? Because that's what I'm converting this to. And yes, there is. There are 5,280 feet to 1 mile. And I can cancel my feet here with my foot here. And since miles is what I'm looking for, I'm done with that part of it. Now I look and see what units are not crossed off. Miles are not crossed off, and seconds. So if I were to leave this alone, and I were to multiply 1100 times 1, and this 1 times 5,280, and then divide 1100 by 5,280, that would tell me how many miles per second this chairlift travels. Well, I'm not interested in miles per second, and since those are the only two things that aren't crossed off, that's what it's given me. I need to change the second to hours, so then I have miles per hour. So I'm not done yet because my units are going to be miles per second. So I'm going to change the second to hours. So what I do is I make another time sign, another line, and notice that when I was changing feet to miles, I had a foot up here and I put a foot down here so that the feet would cancel. Same is true here with seconds, but I have a second on the bottom, so I'm going to put a second on the top because I want those to cancel. Now I'm changing those seconds to hours. Do I know anything about how many seconds there are in an hour? I have no clue. What do I know with seconds? I know that there's 60 seconds in 1 minute. Now I can cancel my second here and my second here. So now what I'm left with is miles per minute. Well, I'm not interested in minutes, I'm interested in hours, so I'm going to keep going. Another times, another line. And again, I've got a minute down here, so I have to put a minute up there. And do I know anything about minutes and hours, since hours is where I'm going? Yes, I do. I know that there are 60 minutes in 1 hour. Alright, so now where I'm at is I can cross out my minute here with my minute here, and what I'm left with, I haven't canceled my hours, I haven't canceled my miles. So I am where I want. I'm miles per hour. Miles on top, hours on the bottom. So what I'm going to do here is I'm going to multiply everything across the top. So I've got 1,100 times 60, because it's of my 60 seconds here, times 60 right here. And that's going to be divided by 5,280, and I don't care what the endings are, I'm just multiplying my numbers. And then the rest of the numbers in the denominator are ones. So at this point I'm done. So I'm going to multiply 1,100 times 60 times 60, and then divide that number by 5,280, and I get 750 miles per hour, or 750 miles per hour. So therefore, I realize that this chairlift speed is not correct, because I doubt very much that a ski resort's chairlift is going to go 750 miles per hour. It's a little bit speedy. So that's how I prove that that speed is incorrect. So that is the lectures over 7.1.